And welcome back, everybody, for continuation of Lesson 4-10. We've been talking about two-step equations, but we're going to focus a lot today on simplifying things, making our lives simpler. Keep those terms down at the bottom in mind, groups and like terms, keep that fresh in your mind. Meanwhile, changed up the assignment slightly. We go ahead and hit pause, check your answers from the previous day. Come on back when you're ready. So again, we have been at one and two-step equations, but we need to be prepared for some more complex equations. So we're going to move back to expressions, almost like taking a step back before we take a step forward. So our goal today, I will identify and combine like terms in an expression, and I will use the distributive property to simplify. Remember, we're focused on like terms in groups and like terms in groups. So keep those in mind. File your homework paper. Come on back when you're ready. So, what is the distributive property? Let's review something that I hope we've learned from 6th grade. It is where we multiply each term by the number outside of the parentheses, term being the key mathematical word here. And you might have guessed it, you've heard it, you've seen it before this year, where we use the distributive property to simplify our lives, making our multiplication easier. As an example, 5 times 23, kind of difficult to do that unless you break up 23. And you say, well, I know what 5 20s are. 5 20s are 100. I know what 5 3s are. 5 3s are 15. Oh, okay. So 5 23s would be 115. We have used the distributive property for all numeric expressions with just numbers. But what happens when we have a term with a variable inside? All right. One thing I really want you to focus on is repeated addition. What does that 3 mean? That 3 is not like $3. It is 3 groups of X and 5 and X and 5 and X and 5. So we have a money bag and 5 extra bucks, and another money bag, same amount of money, with 5 extra bucks, and a third group of a money bag and 5 extra bucks. This is a visual model of what that would look like. 3 groups of X and $5. Okay, well, let's combine those like terms. Why say 3 groups of X when you could say 3 X's? Why say 3 groups of 5 when you could say 15? Sooner or later, I'd love you to be able to do this without drawing a model. Why write 3 groups of X when you could simply write 3 X's? And why write 3 groups of 5 when you could write 15? Last but not least, please remember you cannot combine those into 18 X's. I mean, after all, you have some money bags here that we don't know how much that is. All right. What about if you have more than 2 terms inside of the parentheses? Well, again, what does that 5 mean? It means 5 groups, right? 1 and 2, 3, 4, and 5. And by the way, does anybody remember what we would do with those negative 5s? Now, some of you do just fine with subtraction. The rest of us will change it into adding the opposite. But think about this. Why write 3 X's repeatedly when you could say 5 groups of 3 X's? 15 X's. Why write 2 Y's repeatedly when you could say, well, listen, 5 groups of 2 Y's, that would be 10 Y's. And why write negative 5 repeatedly when you could say 5 negative 5s is a negative 25? So just remember, please, that you cannot combine these to make 25. Well, what would it be? 25x? No, maybe it's 25. Well, no, those are not like terms. X is one particular amount of money, Y is another particular amount, and neither of those are known. Therefore, this is the simplified algebraic expression. Not perfect, we still have unknown amounts, but at least it's simpler than this silliness up top with a number outside of a parentheses. Why write 5 groups of something when you can actually simplify it out? So pause if you need to and try to figure these out on your own. For the rest of us, let's take a look. 7 groups of Y's, 7 Y's, 7 groups of 3, 21. Final answer is 7 Y's and 21. 8 groups of M would be 8 M's. But listen now, 8 groups of -1 would be -8. Some of you will prefer to change it to adding the opposite and seeing 8 M's plus a -8. 5 groups of 4X's would be 20 X's. 5 groups of -5's would be -25. And again, you are more than welcome to change subtraction into adding the opposite. Now I saved the last one because this one seems to be a little trickier. 9 groups of 4n's. Now I'm not going to draw all this out, but I want you just to imagine what 9 groups of 4n's would look like. Maybe I'll put a little ... here at the end. But wait a second. That's not just 9 groups. That says take 9 groups and then take the opposite. So how do you take the opposite of all those? Well, the opposite of all those positive 4's would be -4's. And the opposite of all those positive 2n's would be -2n's. Therefore, 9 groups of 4, 36, the opposite of which would be negative. 9 groups of 2n's, 18n's, the opposite of that would be negative. And while this is a good answer, it's not a great answer. I really want to get you ready for high school, where we will always put the term with the variable first, and then the constant term at the end. Again, you may write subtract 36 or add the opposite of 36. So beware when you have that opposite symbol. Sure, take your groups, then do the opposite. If you wish, you could always simply write in the terms first, then I'll go back and say, okay, the opposite of a positive is a negative, the opposite of a positive is a negative. What happens if you have a group and some extra terms at the end? Well, if you think about this, the first thing we can do is get rid of those groups. Why write 3 groups of X when you could write 3 X's? Why write 3 groups of 3 when you could write 9? But now we see some like terms here. If we use the commutative property, remembering that you can do that with addition, you can change the order and now use the, well, most of you can skip step 4. If you see 3 X's and you see 7 X's, you know right away that you can combine some like terms. Once again, just a reminder, that will not change to 19 X's. If you envision this repeated addition, you have a bunch of X's, and then you have a bunch of known quantities, so you cannot combine those. Now what we'll do, I will do this live in class, is we're going to complete this together as a class. I'll give you the front side, I'll give you time to do that, I'll give you the back side, I'll give you time to do that, and then we will get into the homework. And the homework's only, I want to say it was only 8 problems, I believe. So this should be done, quote unquote, in class, even though we're at home. If you wish, you can go ahead and get ahead, but I'm not asking you to. Again, we'll plan on doing this together. And then I'll put the answers up ever so quickly, and then I'll end the video. Big part of this is going to be the drawing. I feel a quiz question coming on. Can you draw? Do you understand what groups are and why we in fact multiply? Because it's repeated addition, right? This feels like a perfect quiz question. All right, that's all I have for today, folks. If you haven't stopped the video already, please continue on with that homework assignment. More two-step equations with integers. I'll give you the answers tomorrow. See you.